rest of this chapter then. So, then you have weaknesses in handling that session token after you've made it. People think that SSL will protect the token, but it doesn't really. It only protects it from someone eavesdropping on the traffic. There are a bunch of other attacks that will still steal even a cookie that is encrypted with SSL. Now, if you don't encrypt it, then you can sniff it from anybody using the same Wi-Fi, with anybody in the ISP you go through, or anybody that gets their hands on the packets can read it. So that's really bad. Now, if you steal a password, it still might not work because you might have two-factor authentication, where you need a PIN also, or you might log in over HTTPS, so you can't get the password. But even if you can't get the password, if you can steal a session token, you can often connect, and they won't be identified of a login because you don't do a login. You're just still using their logged-in session. And as I mentioned before, this happened to me. This was quite common 10 years ago, that sites would use HTTPS during login, but then switch to HTTP afterwards and send the cookie through unencrypted traffic. But that's finally pretty much over. Gmail quit doing it in 2012, and that shamed everybody else into switching to always HTTPS too. All right. And you might use HTTP for pre-authenticated pages before you log in, and then when you log in, continue to use the same token, and that's bad, of course, because then the token was previously sent without encryption, and after you log in, that token is now used to identify you, so you really need to make a new token when people log in. And you might use the back button, so if you went from an HTTP page to an HTTPS page to log in, but then you went back, that would send the token without encryption over the network to the server. These are other bad things that can happen to you. SSL strip is an amazing attack. You just put up, Burp can do this, by the way. You can have Burp remove HTTPS. So any proxy can do this. It can load the page over HTTPS and then serve it over HTTP. So you'll see the page, but nothing's encrypted. It looks fine, but there won't be a little padlock in the URL bar, which almost nobody ever notices anyway. And then there used to be a lot of these mixed content pages where you'd have an HTTPS page that contains some HTTP content, like ads. And this is unsafe because the HTTP content can be changed by a proxy, and you can add scripts to it, which will run in your browser. So everything has to be completely HTTPS, or you have serious security weaknesses. So then you can use social engineering. If the app uses HTTPS for every page, you can just send them an HTTP version by a phishing link, and when they click it, it may take the session token stored in their browser and send it over HTTP somewhere. So they may fool them. So there's steps here. Notice every session token. Notice when it transitions between HTTP and HTTPS, and those are your likely danger spots. So I got a little example of this. I wrote a demo years ago, and it's still somewhat worth seeing. So here is a login page. Now I'm going to delete all the cookies. You can do that by just clicking on the icon up here, Cookies and Site Data. And there, this guy should be able to manage on-site device data there. I throw away the cookie. Okay, now there is no cookie on this page. And so if I click this, this is going to run JavaScript alert. I'll reload the page. It says, okay, alert document cookie. So there's the alert, and there's no data in there. There is no cookie. But now when I log in as user and password, I log in. Now I'm welcome user. I've logged in. If I go back here and use that, now I'll see the cookie is username 1 equals user. So I just stored the name of the user. That was the cookie to prove that you've logged in. This is, of course, a bad practice, but you can see what the cookie does. Now, I'm going to clear that cookie. So go up here, Cookies and Site Data, and delete that cookie. Okay, now it's gone. Reload the page. If I click this, there's no cookie. Now I'm going to log in down here. But the difference this time, let me show you this in the browser here. If I clear the old stuff, clear history, okay, yes. Okay, now I'm going to log in here. And let's go look and see the request that did that. Here's the request. There. Here's the cookie. It's sent up username to your user. But when you see where that was set, here is the request. I think this is the one where I logged in. Yeah, here I am passing username and password up to the server. And the response to that from the server had a set cookie. To set cookie username 2 equals user. All right, but notice these flags. It added secure and HTTP only to the cookie. which the previous page did not do. So the cookie is stored in my browser. It knows who I am. But if I try to fetch it with this alert, I will see nothing, because this is JavaScript, that's not HTTP. This is what happens. The cookie was sent with secure and HTTP only. And secure means it will only move over HTTPS connections, not HTTP connections. And HTTP only means it will only send it to HTTP. It will not send it through JavaScript. And you can test it. This is alert 1. You can see the 1. And this is alert document cookie, but it won't let you see the cookie. So, of course, you can't trust these. This tells the browser to enforce those rules, and you don't have any way to know if it really did enforce those rules. But that's the purpose of this. All right. Anyway, just thought I'd show you those. Those demonstrate a couple of simple things about cookie handling and transmission. Would you recommend the API book for a beginner? Well, it's pretty easy, and all my projects in that section are from the API book. So I ran a server. So if you get that book, you'll just be essentially doing the same thing as those projects. It's pretty easy. It's no harder than the Web Security Academy.
How about when you enforce HTTPS? Because browsers give you the option to enforce HTTPS for all websites.
Yes, that's an option now. Enforce HTTP. It will never load anything over HTTP at all, which is probably pretty harmless these days. Almost nobody uses HTTP for anything. But that's an option, and that would prevent that attack where you trick them into going to an HTTP version of a page. So it'd probably be a little bit more secure. I don't think there's too many people doing that, but it will stop that attack. So that's the game. All right, we've seen this, the secure cookie. All right, so that's how you set a secure cookie. You've seen that. And when you transmit it, all right.
One question.
Yeah.
What about if you say, stay logged in? That puts you at risk.
Right, if you say stay logged in, then it stores the cookie on your machine and it sends it. But if it sends it over HTTPS, the risk is pretty small.
Okay.
That's no worse than just logging in again. So I mean, that's very common. All right, anyway, so we've done all that. All right, and by the way, HSTS is another enhancement, strict transport security. And I think this is one that was, once a browser receives this header, it will now know that it should be only using HTTPS for the page. This is recommended. You put this header on your server, and that tells everybody's browser, never connect to this site or HTTP. Of course, as you're saying, nowadays you could just set your browser to always use HTTPS and never HTTP at all, and that would probably be fine. This was a useful thing in the transition period, where some people are using HTTP and some are using HTTPS. All right, and then logs. This can happen. Logs might disclose cookies. Logs often record whole requests, and then somebody might be able to read the logs and get cookies out of there. So if there's a Google dork, this might still work. This is a Google dork to find Java JSON session IDs in cookies. Let's try it here. If I open Google and I do this search in URL JSession ID. These are pages about JSession ID, but I may be able to find pages that accidentally have this. I was able to find it maybe a year or two ago pretty easily. JSession ID. Looks like I'm not going to find that many. Now Google is sort of, see if they catch me. App authorization, JSession ID and Spring Security, that's still describing it. Yeah, looks like maybe this one is not going to work today. There are others that do. Quick View. I don't know, this one might do it. Oracle Business Intelligence Global Action Plan. This is beginning to look like it. Oracle Business Intelligence Finder. Okay, these look like they might be revealing JSession IDs. Let's see what these pages are. Accounts, backspace. Yep, here's a JSession ID in the URL. This is somebody's session ID. Now, probably not a live session ID, but again, that's a question. Here's another one with JSession ID live up there. And here's another one with a JSession ID. And see, if they put the session ID up here, then any log that records the traffic will be recording it, and a favorite would track. Like I said, you never put confidential information up here in the URL, and there's a bunch of people doing that. It's a mistake a lot of them are making. All right, and then here's the Center of Disease Control doing it a while ago, putting JSession ID up there in the token where they really shouldn't be putting it. So if you put them there, it'll appear in the browser logs, the web server logs, proxy servers, the referrer log. if you go to another page, it'll send that whole thing, including the site ID, as the referrer to the next site. So all I could do is send you, hey, look at this, click on this link. And when you click on the link, it'll send me your session ID because it was right up there. That's why you shouldn't be putting confidential data up there in the URL. All right, and there it is. Here's the JSession ID, and there's being sent as a referrer to the next page. So it's a poor practice to put that data up there. All right. And so you can have a vulnerable map, and if the user is able to have two sessions open at the same time with the same token, then, and this is quite common, then that sort of means there should be two separate sessions, but they aren't. And so here's another logic where they have the username and an R1, which is some kind of identifier of time or something. Anyway, I'm not going to worry about that one. I don't know what the point of that one was. So another thing I found to be true of many sites is that you log in, you get a token, you log out, but the token still works. And so this turned out to be true of about half the sites. I did a test of it. I found out it was true of Office 365, and I found a ton of other web services that has this vulnerability. American Express, a bunch of other ones. I did a bunch of these, and that's pretty appalling. I don't understand exactly what the server-side code is that does this, but this means if I can steal your token, you're screwed. You can even change your password and log out, and I can still get in. The only thing you can do is delete your account to stop me from getting in. And this was true of about half the web services I tested a few years ago. So that's cookie theft. There's one way to get in. Another thing I can do is sometimes I can feed you a token value in the URL, and when you log in, it'll keep that token value. So I can provide it to you, and it'll then be authentic. After you authenticate, then it's active. That's session fixation. Cross-site request forgery is tricking you into submitting a request containing a cookie. That's where I might have a link that goes to like Amazon, and because you're already logged into Amazon, your browser adds a cookie, and now you buy my book without meaning to, you know. If you set a cookie, you can specify the domain and URL it's good for. By default, our subdomains are included. So if I have a cookie set by games.samsclass.info, it will send it to foo.games.samsclass.info, but not samsclass.info. Anything that contains this URL will be included. It'll get the cookie. So if you set this cookie going to yapp.com, it will now send it to bar.yapp.com. A domain can set a cookie for the same domain or a parent domain. You can't set a cookie at a top-level domain like .com. That would really be bad. It would go to everybody. So blogs.com sets a cookie for each user. Each user can create blogs, joe.blogs.com and sally.blogs.com. But that means a blog with JavaScript could steal token of other people. It set the cookie for blog.com, so the same cookie could in principle be sent to a different user. This is a poor plan. The right way to do this is to use a different domain name for the main app and scope it. So use the main app www.blogs.com, and now it won't be sent to joe.blogs.com because it doesn't have the www in it. That's a way to avoid that. All right, and so you can have the path here, which shows that it'll to resubmit this cookie to subdirectories as the app's path. All right. And so if you're able to put a malicious page on the app's path, you'll get the cookie. This is the trick. If you can somehow meet the requirements, you can steal cookies that way. So to secure session management, this is just a review. Make strong tokens, protect them through their life cycle, use a large set of possible values and a strong source of pseudo-randomness so they're unpredictable. They should not have any meaning. They should not be encrypted or encoded meaningful data like username. All the data, meaningful data should be stored on the server, and it should just be a random number. Be aware that some of the random functions given to you by languages are not very random. So their sources of entropy, there's a lot of them. A good method is add a secret key known only to the server, add a random number, and then hash it. That's one way to do it. Only transmit everything over HTTPS with secure and HTTP only. Don't put those tokens in the URL, like those JSession IDs, and implement a logout function. When you log out, that should invalidate the old session token. It's appalling that it doesn't. There must be some popular software product that doesn't, and people don't know it. I don't know enough about the way they code these websites on the server side to know what it is, but like I say, half the websites I tested did not invalidate old cookies, which is a pretty serious flaw. Sessions should expire. This is a recommendation, although most people won't do this. This is sort of appalling because everybody's using cell phones, and you don't want to type your password again on a cell phone. So I don't think anybody has your stuff expire except Chase Bank does. But that's anyway. Don't allow people to log in multiple times at the same time from different devices. This also, everybody allows this now because everybody will use the web and then they'll use their phone and they want to get the account on both of them at the same time. So these are recommendations from your textbook, but I think they are so impractical. Nobody does this.
Actually, there is one factor that you're missing.
Yes, that.
If you log into Chase Bank, I think it'll say your browser's expired. You cannot log in.
That's right. It does expire.
They have
Yeah.
browser rejection.
Yeah, the bank does expire after 10 minutes.
No. I'm talking about the browser. If your browser's too old.
Oh, yes. If your browser's too old, a lot of.
You cannot log in.
That's right.
Browser's rejected.
That's right. A lot of them will reject you if your browser's out of
Do the
date.
same thing with the cookie. If they had a program to browser rejection, could you use the same kind of programming to do cookie rejection?
Well, I don't think it's the
Maybe
same.
not browser rejection. Somehow you determine what version of browser I'm using.
Well,
Or
I
you
think.
just determine how the date of the cookie and say, we no longer accept this cookie, it's been past 14 days.
Well, it's a similar thing. I mean, it checks the browser version, and if it's below a certain number, it rejects it. And you can check the cookie can have a timeout value.
Yeah,
Yeah, that's right.
it's doable.
That's always it's totally doable. The only problem is it'll irritate your users when they keep having to type in the password again on a cell phone.
Yeah.
So that's why people don't like doing it. All right, and so restrict the domain and path for session cookies. Watch out for cross-site scripting vulnerabilities, which is how you get to inject code, bounce code off the server, and therefore create pages that appear to be using code from the server. Chase Bank had a separate issue recently. Oh, I didn't know about that, but I know, I don't know, a student said that. I don't know what it is. All right, don't accept tokens submitted by unrecognized users. This would be a good idea. Two-factor authentication is one that really is taking off. A lot of sites use that now. That really helps a lot. And using hidden fields rather than session cookies, this is a better thing. You have a hidden field the server sends you that has to come back. That means you really are using a browser. You're not doing something else like using burp or a stolen cookie. So create a fetch session after every authentication so that people can't use an old session token. That would be a very good idea. And you can have per page tokens where you make a separate token each time you request a page. And this verifies every page has a hidden field, and every request verifies the hidden field. That means they were on page 1 of my site, and then they went to page 2, and then they went to page 3. They didn't just record an old thing, send it to Burp Repeater, and send it again. This is a way to prevent people from repeating stolen information from the past. They have a random number that changes all the time that has to be included in every request. That's a way to prevent a whole bunch of these attacks. Forcing them to really be going through your website, through the pages in the order you want them to, and not any kind of replay of old data. And so here's per page tokens used in here. You have a hidden field with just a different random number on every page. And so you verify it every time to make sure they really got the number that you sent that browser before. And whatever you're doing, log. And if anything funny is going on, log it. Maybe terminate the session. Then you know when you're under attack, and you terminate the sessions of people that are trying to attack you. This is a very good idea, network security monitoring. So terminate a session if the request has modified a hidden form field, has strings associated with SQL injection or cross-site scripting, or something else that violates your restrictions. Any of these things indicate that this is an attacker. This is not a legitimate user using a browser. Let's see something here. It was people going to cash fraudulent checks and immediately withdrawing that money. Well, yeah, that's another issue. Yeah, they used to call it check kiting. All right.
Actually, there was one more security feature for US Bank.
Yeah.
They used to remember what gateway we went from, like Xfinity or some other service.
Really?
If the gateway didn't match, they'll say like, I don't think this is you because this is not your normal gateway.
I know a lot of my services do that. They say you're logging in from an unknown device if I take my
No, not
laptop.
device, gateway, as in.
Yeah, but if I take my laptop to a coffee house, it notices I have a different IP address or something. Yeah, that's true. All right, let's try this here. Yep, that's right. They try to notice anything fishy. And coming in from a different location will do it, especially another country when you're traveling. Then they figure that's probably an evil attacker. Yeah. All right, so what does HTTPS prevent? Yep. Sniffing wireless transmissions will not work because it's encrypted. These other techniques will still work. All right, what prevents users from clicking through an SSL warning? Your browser will sometimes pop up and say, this certificate is not acceptable. That's what HSTS does. It tells it this page must be loaded over HTTPS. Do not allow it to load if there's anything wrong with the HTTPS. That's the purpose of this header. And then it will not present the user an opportunity to go to the page without HTTPS. It will just refuse to load the page. All right, what defense protects cookies from theft via JavaScript? This has been one very common way used. HTTP only means it'll only transmit it over HTTP, not over JavaScript, which is a different protocol. All right. What should a logout button do? Should terminate the session on a server. What most of them seem to do is just delete the cookie from your browser, which is not the same thing. All right, what kind of session token is not sent on every request? Hidden fields. I sent it to you for one page. When you click on it, it'll come back, but just for that one page, not for future pages. So it verifies that you actually used the page I wanted you to use to send this request. All right, what should happen when a server receives a request with a modified hidden form field? Terminate the session. This is an evil attacker. It can't be a normal user using a browser. They must be using an attack tool like Burp. So there's no point popping up a message to them. They know they're an attacker. Terminate the session on the server. They're a bad person trying to get in. So let me stop this recording.